want to make sure we cover, guys, is let's look at what we got here. So we have sine of u equals 4 over 5, and cotangent is greater than 0. Now, again, if we're thinking about sine of u equals 4 over 5, we're so used to using the unit circle, but we don't really recognize that 4/5 as a y coordinate on the unit circle, right? We just don't recognize evaluating it that way. So immediately, probably the easiest thing to recognize this would be a triangle. But we just can't write any random triangle that we want to because I'm using theta. I'm reverting back to old techniques. We recognize that the angle of u, though, has to be positive. So we have a restriction, right? Remember, we spent a whole class period actually talking about this stuff? So cotangent is positive in the first and the fourth quadrant. Sine is also positive. Now remember, there was only so many ways that we wrote these triangles. They have to have the central angle, and they have to have your 90-degree angle is perpendicular with the x-axis. Right? You guys remember this? Yeah. So therefore, we'd say this is 4 over 5. Now, if we want to find this other missing side, we could use a Pythagorean theorem, or we could recognize that this is the Pythagorean triple, and this side is 3. OK. Now, in this next one, we have cosine is a negative 3 over 5, but sine is going to be positive. So we recognize this is not the same triangle because our adjacent side is now negative. But sine is positive. Therefore, that's telling me that's in the second quadrant. So that's a negative 3. And that's a 5. Therefore, using the Pythagorean theorem, we can see that that's going to be a 4.
OK, so they're going to be in that area.
Yeah. Now, the question actually is to evaluate. So we need to evaluate u minus v. So again, let's just plug in the formula. So we have tangent of u minus v equals tangent of u minus tangent of v all over 1 plus tangent of u tangent of v. OK? And now, guys, we're not using the unit circle to evaluate these, but we are using the triangles to evaluate. So do we know what tangent of u is? 4 over 3. So we have 4 over 3 minus tangent of v, four over negative 3. Divided 1 plus tangent of u, which is 4 over 3, times times negative 4 over 3.
So it's like you point from a triangle, so the unit circle.
Yeah, you're just using triangles.
Okay.
Now, before we actually solve this, now this one's not too bad. I actually was doing some other problems with other groups, and they had some more difficult problems. You guys actually get a pretty easy one. But let's go through the process, because you guys could you guys could add and subtract these fractions, right? But let's think about this. What if we had something more complicated? What would we do? And again, we have fractions within fractions. So to get rid of them, we want to multiply by the common denominator. So what's the common denominator that we have? Yes, you could multiply, well, not actually 3, because when you multiply these together, you actually get 9. So this expression has a denominator of 9. And then these are 3 and 3. So the common denominator is actually 9, actually.
OK, so if you times those together, you get actually 9 instead of 3 as common.
So watch what happens when I multiply everything times 9. Because you have to multiply every expression. So when I multiply every expression times 9, 9 times 4 is 36 divided by 3, or you can divide out the 3. You get 12. This is obviously a positive. So that's going to be, again, another plus 12. All over 9. And that's actually minus 4 times 4 is a minus 16. Right? Because that's a negative 4/3. So therefore, I'm getting a 24 over, 24 over 7. Yes? No? Anybody saying besides? I think I'm good. Yes? How did I get what? So if you were to like kind of simplify this real quick, you get 4/3 plus 4/3, 1 minus 16/9. So if you were to like kind of simplify this a little bit, you'd get this. And now you can see the common denominators of my denominators are 3 and 9, so it's 9.
You can simplify down for example, it was 9, not 4 is common denominator.
Right. Because the 3 was an expression by itself. It was multiplied by another 3.